Happy Monday! Welcome to the Monday Morning Data Chat. Every Monday morning, Joe Reese and Matt Housley have candid and unscripted chats about all things data, sometimes with special guests. If you want unfiltered and honest conversations about data engineering, data architecture, data science, and analytics, this is the show for you. It's time to chat, so let's get going. Happy Monday. How's it going, everybody?
Going well. Happy Monday.
Happy Monday. Never seen so many people excited for Monday. This is great.
Well, I got my coffee here, so
good.
So yeah,
Same thing.
All right.
I probably need more, but I'll be stuck with this for the next hour.
Awesome. Well, welcome, Andy. Today we have Andy Dang from WhyLabs. For people who don't know who you are, do you want to give a quick intro about who you are and what you're up to?
Yeah, my name is Andy Dang. I'm the co-founder and the tech lead at WhyLabs. And my background is around big data pipelines and data engineering. And then as part of that workflow, somehow I crossed over into the world of data science because turned out at Amazon, where I was with before for 5 years, scientists ended up needing a lot of data to interact, and there's a huge gap between data engineering versus data science workflow, and I ended up getting stuck in the middle of the two problems, which turned out to be quite fun and quite an unsolved problem. And I got to learn a lot more about machine learning and all the kind of and the effect of data engineering versus machine learning. And so I ended up here today being at WhyLabs, where we're trying to solve the problem of data observability and machine learning and data health monitoring from just taking the experience of running these pipelines and building this, helping scientists building models. I can't claim that I build models myself, but mostly being the sidekick for the scientists.
That's awesome. Yeah, it sounds like when you're at Amazon, you're in the really early days of I guess what is now called ML engineering or ML ops. Walk me, what was it like back then? I mean, there weren't a lot of resources available, from what I recall. If you wanted to do machine learning in production, how did you figure things out back then?
So one thing about Amazon is that the tooling is way more restrictive than what people perceive it to be, being kind of like, building AWS. But in fact, at Amazon, it took a while to migrate to AWS. So we were kind of like, we're always kind of behind the curve a lot. So my team back then, we obviously we learned. On the other hand, we got to be really close to our customers because the ticketing system is completely open. So we get to know all the struggles that customers have when it comes to the workflow and the interaction. So you can go to the tons of tickets and read about these user stories. So that kind of built up a good initial starting point to find out which are the low-hanging fruits to solve first. But then from the technology point of view, it was weird in the way that we had to build it with the constraint of Amazon. So they had their own internal build system and internal packaging management system, all of which are geared towards software development, and it is a huge friction for scientists. For example, we didn't have an internal PyPy back then, so that was that you couldn't really easily do a pip install. So we had to be in the world of Devops and machine learning ops, like bringing data access and software like library access for both scientists, and then of course all of this, like putting together. You have to deal with, like, once you have this data and the library, you turn out like you have to deal with things like software licensing versus like managing all that security, which a lot of companies that are managing on your behalf, like JFrog, do things like license scan, and data security, which of course in Amazon they wouldn't let a third-party company come in and manage the company's data security. So we had to build a lot of tools around audit log and access log. So it was a very different world, and I wish we had Kubernetes back then. It would have solved a lot of problems in terms of like compute separation and data access and logging and the infrastructure around that.
Martin says not being able to do a pip install is the stuff of nightmares. It sounds
Oh,
like
it definitely was a stuff of nightmare, and the Python ecosystem does not help itself. Like the way pip manages the dependency system did not help. I think they've solved that problem nowadays by building a pip layer on top of the packaging system. That's what I've heard. But back then it was definitely a huge barrier for scientists.
right. Yeah, and I imagine Conda probably wasn't like congruent with your systems as well, so you're not gonna
Right.
go that route. So that's interesting.
Yeah, Conda was not approved because it wasn't something we built ourselves.
Not invented here, basically, but you're Amazon. I mean, it makes sense.
Yeah.
But then we also were a team of 10 people, so we were not like that huge from that's to support these workflows of thousands of people.
That's interesting. But then, I mean, kind of fast forward to today, and Matt and I sort of made up holiday month called Observability October. What is observability? I hear this word a lot. I think I know what it means. Sometimes I don't feel like I know what it means. What do you think observability means?
So from my point of view, like I'm really biased towards data engineering workflows because that's my background. So for me, data observability is the ability to really walk through this every step of your transformation and understand first of all the overall health or statistics and health of your data, and then the ability to pinpoint what we call the long tail problem or anomalies in distributions. Those tends to be meaningful in terms of, and then there are certain other criteria for data health as well, like schema changes, new transformations that changes the distribution or new features. So in a way, like column and feature kind of interchangeable a little bit. And then once you get into the deep learning, you can talk about the health of the embeddings by defining criteria like how many clusters there are in the embeddings. But that is, again, like that's a more complex use case of data health. But coming back from the original, like we can think of data health as just like monitoring the expectation of signals that flows through your system, because in a way there's cases where data is healthy by definition, like the pipeline is healthy because customer data is coming in, but then something like COVID happens, and then of course the data changes, the pipeline is healthy, but now all the distributions are out of band, and kind of like the constraints or the strips of data are significant, and then you'll have to if your system are dependent on these signals, then you have to re-engineer those. So for me, that data observability is really how we get insight of every step of the pipeline and how we can drive actions to really think about like retrain downstream system, readjust our computation, or even little things like scale out our cluster in some cases to it kind of DevOps. If you think about DevOps, it's just more like responding to the data rather than the DevOps signals.
And that's the problem. I mean, Joe and I have talked about this a lot. Data inherently, like you're saying about COVID, is entropic, right? DevOps, you're looking for fairly simple signals, like what is the latency of my web requests? So they're taking longer than usual. How many failed requests are there? Am I seeing way more requests than usual? Fairly simple, not statistically, you're not using complex distributions or anything like this. Whereas with data, if something goes out of distribution, it could mean that there's something that's gone viral and people are hitting your site because they've seen a new product, or it could mean that you're under attack, or it could mean that someone turned on a testing tool that's hitting your site with weird requests and you're getting data that you don't want to show up in your data sets. It's like you guys have attacked a very, very hard problem with, I love this term, data health. Like it's incredibly difficult.
Yeah, I like that term too.
Yeah, and just even for us, like thinking about what are the signals to collect to really figure out the story of data health is challenging on itself, because from my point of view, like looking at data health is like a huge number of dimensions. I've seen data set where people throw in like 10,000 number of features, and these are tabular features. If you look at like fraud detection models, they have thousands of features, and if you use apply traditional even DevOps, like one metric per feature, that's 10,000 metrics, and those are first expensive because they charge per metrics in this DevOps system, whatever. But the challenge is like, as human, how do we interpret 10,000 signals at once? And in all honesty, we have some idea, but it's a very hard problem to solve. It's not really a machine learning problem itself. It is the human, like more like user experience design workflow through this as well.
That's interesting.
Who coined the term data health? I'm curious about that because maybe I've heard it before, but I think the first time I've seen it is today, and I'm like, that actually really resonates because we are familiar with the term like data observability, data monitoring, but I think data health really encapsulates this concept way better than anything else I've heard.
Who coined that term? I don't know, but somebody in my team who was rewriting the website apparently came up with that term. It's not me.
Yeah, that's interesting. I'm gonna have to dig into it. I feel like I've heard variations of this over the years, but it was kind of like, it's one of those things where what's old might be new again, or what is, or it might just be entirely new. I have no idea. So you hear enough things, and you're kind of like, did I hear that before or not? I have no idea. And also,
For me, a lot of the things, like at least when it comes to operating a pipeline, like monitoring a pipeline is definitely a new problem, but monitoring a data pipeline, but operating it is a lot of reminiscence of DevOps world, except that the requirements have changed. It's like we have these kind of like all sort of like traceability, lineage, Git based versioning for some people, or schema versioning, etc., etc. So a lot of versioning, a lot of lineage, a lot of the audit log, and then a lot of guardrails. What kind of guardrails they are going to be different, but very similar. So just again, my background in Amazon, I had to build a data platform or machine learning platform on top of existing DevOps tools. So I worked with these constraints. Like I didn't have the novel tools that we got nowadays to really tackle the problem back then, or even the understanding of it to tackle the problem at that depth. So a lot of my thinking comes from, like, I have no shame of claiming that I take a lot of inspiration from DevOps world, because those are very well battled principles from at least the operational side of things. Maybe not the actual what they do, but a lot of the how and the process are very battle tested.
for sure. Yeah, I mean, similarly, back when I was doing getting into ML back in the kind of early 2000s or 2010s, it's very similar. There wasn't really a playbook on how to do any of this stuff. Like you could figure out how to make a model, but then putting it into production, it's like, well, what does that even mean exactly? And so, companies, I think certain companies, I think the bigger companies, bigger tech companies had their own ways of doing it, but there wasn't like the ML ops community that you have now, where people are sharing knowledge, and there's countless tools out there to help. Back then, it was kind of like you had to seek inspiration where you could find it. In a lot of cases, you're just making it up as you go along, because there wasn't really a
yeah, I mean, even in Amazon, I remember in 2014, I was using Excel sheet to track model parameters. I know we're laughing at that, but it's ridiculous. But then, we were serving like tens of thousands of requests per second, and we were like the stack itself was incredible in terms of scaling, but the kind of like model operation flow behind it was completely untouched. It's like, here, make sure you drop the Excel spreadsheet in the right location when you deploy the model, and name it in the correct name for the A/B experiment. So we have A/B experiment or all the statistical tests, but we didn't have a way to really like store the model metadata information alongside with it.
That's pretty awesome, actually.
I bet it's still the case at a lot of companies, let's be honest, like, which is why you guys are in business. It's like, no, let's come in and help you to solve this problem, so you're not trying to do it yourselves, reinventing the wheel.
Yeah, I mean, model tracking is definitely hard because the deployment infrastructure can vary so much across different companies. Everyone that you tend to hear about certain technology, but all I see is Frankensteins in actual deployment environments, where people put together Frankenstein pieces of like Qflow in one area, and then suddenly they drop in Databricks, and suddenly there's Snowflake, and then Fivetran somewhere upstream, and then downstream is just like serving is SageMaker or Azure.
Got a question here from Magenta. Hi there. How does data observability help address data pipeline failure?
I think data observability helps addressing data failures by surfacing signals that are tied to the data. And by data failure, well, it really comes to what failure means here. Are you talking about failure to run a Spark job to deliver the data to the destination? Or are you talking about the failure of, for example, a bug that was introduced in the transformation step somewhere that causes the data distribution to shift? And I think data observability can definitely address the first one because it's going to be the missing data case, for example. But the second one is the more challenging one where data distribution gets shifted because of a bad transformation. That's where data observability can really help and can also surface, could be a cascading effects. It could be the bug in two places in the pipelines that cause this sort of data pipeline failure issue. And more importantly, it allows us, if you can deploy observability to production endpoints, that's where it's most valuable, because you really want to make sure that the data your production system receives matches what the data that it was trained on or was built on, like the test or the development data set. And that's what, if you have an end-to-end view of this, or you can do side-by-side comparison, and in fact side-by-side comparison is more intuitive to humans, then you can detect these sort of data failures that are hidden from traditional DevOps monitoring.
Yeah, I think Matt and I have we always talk about how data is like a silent killer in a lot of ways. I think you hit on this too when you're talking about, your data pipeline might be working, but your data might fail. And I think this happens a lot. Like we see a lot of cases where the pipeline seems to be working, but then the data is like terribly off. But you've been making decisions off of bad data for probably longer than you hope. So, or your models, have been deployed, and that's based on bad data too. And so,
yep,
it's always fun to find that out. So,
yeah, we like have a case of some people deploying zip codes. In zip code is such a common failure, by the way. Some user was deploying zip code, and what they found in production was that they trained the model with the traditional 5-digit zip code, but in production they were receiving data with the dash, the hyphen in the middle, like 8 version, and that causes all weirdness to that model, because the model was like, oh, I don't know what to do. I'm gonna throw a coin, just flip a coin and see what it. And so that's something that I remember vividly. And it's a very simple, very common mistake, or even state names, like long abbreviated state name versus long state name is a very common issue. Yeah.
Yeah.
And they were like, the reason they detected it was like they were looking at the length of the data points, and just suddenly there's a spike in number 6, and normally it's just a flat line, and then there's a spike sudden. So that's how they detected it. But yeah, day-to-day comparison or comparing against like baseline data is very important. Having a good understanding of what good baseline mean is a good first start for really monitoring and enabling observability. Because again, at the end of the day, it's not like DevOps where you can define what a threshold is where across all the features. Maybe if your data and pipelines are small, you can do it easily. But when you have like thousands of features across like 20 data sets, that's going to be much harder to manage manually.
Oh yeah. Back to ops real quick. Mark Keeling has a kind of a 2-part question. One part is, what resources did you use to learn DevOps? And then the second part is, what, if any, differences are there between regular DevOps and data ops? So the first part is, what resources did you use to learn DevOps?
This is a hard question because I don't have a solid list of resources. There are some standard DevOps like Google SRE book that I read that was really huge inspiration, but a lot of it, to be honest, I follow various community, including there's an MLOps community as well that actually like there's a lot of crossover between the two worlds. I also follow. I'm a huge fan of infrastructure as code, so there's a technology called Pulumi that we use at WhyLabs, and I follow their community. And by following community, you know, there's a kind of a networking effect where you find out some people who are hugely influential and you end up reading their blog posts or their LinkedIn profile. And that's how I learned about this kind of like DevOps and way of thinking, tackling these problems. And I watch videos from these conferences, and I also follow the Kubernetes community as well, because Kubernetes obviously the rising star in the DevOps world. And while there's the debate of like how much friction there is to Kubernetes, there's a lot of best practices built into these like Helm charts or Kubernetes recipes, if you don't know what Helm charts are. So that's how I attack this problem, because I tend to learn it along with the job, but also like trying to tie it back to the problem that I'm trying to solve at hand when it comes to ML ops. Like how do ML for ops fit into the DevOps? Like what kind of signal would make sense to translate into DevOps versus keeping it in the data side? And that goes into the next question, I guess.
Yeah.
of differences between regular DevOps and data ops. I think the DevOps deployment pipeline is more linear in a way that if I visualize how we deploy software, is like a semi-linear process with maybe some feedback once you reach production. If you have tests, there's a feedback signal to feedback into the bug like backlog cycle. But in data ops, there's a lot more iteration and especially if you throw in ML ops, in data ops you have like feature transformations, like column transformation of tables. So there's like this sort of iterative process there. And then if you throw in machine learning, then that cycle becomes tightened, a lot tighter, because then you want people to be able to iterate fast on the data. So there's a slight difference there when the speed of iteration is different. And that means is that you need to be able to capture the changes across these iterations much more, at least when between the production versus the testing environment, for example. And then data ops failure I think we talked about this before, don't come just from code, but sometimes it's just the nature of data itself, that customer behavior changes, or just upstream system changes, or the bug from a third party if you consume data from another third party. So there's a lot more complexity, hidden dependencies in the data system than in a traditional DevOps system. I mean, you can argue that service calls are dependencies, but then the service calls might be successful, but then within those, the responses might be broken. And that's what we've seen a lot in practice, is that those hidden failures are harder to detect due to the sheer dimensionality of data. And that's the final difference, from my view, between data ops and DevOps, is that the sheer number of signals you can collect from a data ops pipeline is way more than traditional DevOps. And that's a great question too. And I think we should solidify, as we talk about data ops and machine learning ops versus ML and DevOps, it would be good to solidify these lists.
He has a follow-up question here, Mark. Good questions. It sounds like the deployment cycle would be a lot more frequent in data ops because of the need to update machine learning models. Is that accurate?
It's not really, because you don't want to update your models too frequently. You only want to make updates when it matters. However, what I meant by cycle is the experimentation cycle. When people iterate on a model, they iterate on various parameters. And what scientists do is that they throw in 20 or even 100 combinations of hyperparameters, train the model, or transform the data with these parameters. And then at some point, they spit out a model and they do various tests. And if you don't track the parameters at some point carefully, as an operator of that system, you might not be able to tell that the model is vastly different from the previous one. So that's an example of like the difference in the kind of iteration cycle. Whereas in DevOps, you just do a code, and there's a code review, and then there's some tests, and then that gets deployed. In machine learning, there's a lot of things like when you deploy a new model, it just say, "Hey, here's the ROC curve, and the scores are better, so I'm going to deploy the next iteration of model." It's not necessarily the same as having unit tests or integration tests on a machine learning model. It's not really about the speed.
Yeah, I was gonna say it. Returning too quickly, you potentially would just do dumb things more quickly. Which is might be fun depending how adventurous you are. Where do feature stores fit into data or ML observability?
Yeah, feature store is an interesting beast, in my opinion, because I've seen so many different interesting ways of building feature stores from very primitive approach. I've seen people who dump a whole companies like every day they do a snapshot of the data into DynamoDB. I've seen I think Google Feast has good integration into Bigtable. So just from the technology implementation side, I find it really fascinating. The feature store is definitely, if you can achieve that in a company, that would be amazing, because you get to centralize the knowledge around machine learning and the transformations. The downside of central system, again, is that they add an element of inflexibility into the workflow, because if the feature transformation doesn't fit you, then it comes to question of feature engineering. And now, how do you capture those transformation in an effective manner? You have this DBT out there that allows you to capture and version SQL transformations. But do you want who will own that? Now it comes to the ownership question. Like, if you can capture it, then who's going to execute the transformation? Is going to be the scientists who are working on the features, or is it going to be the data engineer who are working in that, or is it going to be an ML ops engineer? And what I heard is that, so this is from a big customer that we talked to, is that they don't feel they can trust scientists to run feature engineering. And then scientists find it a lot of friction to do, to go across the team, to go to the data engineering team to get features transformed into the feature store. And that's the fine balance that they want to the key thing for a feature store that I haven't heard a good solution for is how to enable scientists to experiment locally or in their environment with their own transformation and translate that transformation into production system effectively. That kind of maybe some sort of data share ownership between the data team and the machine learning team. But that's the challenge of the gap in the feature store world that I've heard so far from talking to various people.
That's interesting. Yeah, go ahead. Sorry, didn't mean to interrupt.
No, it's I love that feature store story, because if we can centralize everything, it makes it easier to monitor. I mean, if we can just simplify from the data monitoring perspective, is if you can simplify the machine learning monitoring into feature store monitoring, then it does simplify at least the machine learning part. It doesn't help with the upstream data pipeline. You still have to solve the challenges for them. But at least when it comes to monitoring model, if you reduce it to just monitoring the feature store.
In principle, go ahead, Joe.
No, Matt, you go for it.
Yeah, so in principle, I mean, you can use a common orchestration platform to allow people to kind of come up with their own table versions, right? And I know some organizations have done this with Airflow, for example, but it does get very complicated, and you can drive really high costs for compute and for storage. And then the question is, whose responsibility is it to clean up, all these old table versions that are running every day, once they're really not being used anymore? So.
Yeah, that's cost is another thing. Is that any feature engineering, it's expensive, especially, and it depends on the scale of your company. If you're operating in the simple SQL world, maybe it's a lot easier to create views. But once you hit the kind of data lake world of Spark or Flink, then that becomes a different equation.
Yeah, for sure. And then you get into the world of unstructured data.
Yeah.
Yeah, again, it's a lot about the ownership, and that is so dependent on the organization that unfortunately that I don't think anyone can solve it easily. It's really gonna be the way I see feature store is that some solution will work for really well for certain organizations, and they will fail for a lot of others simply because of different ownership models.
Interesting. Back to data observability. How does that work with unstructured data?
Yeah, that's a very good question, and that's something that we've actively been working on at WhyLabs. We have image monitoring for observability, and the way we tackle data observability is to think about these data sets from the there's a technique. Well, there's a fancy term called dimensionality reduction technique, which is a fancy term to say take a tons of signal. And I mean, an image is just a blob of binary data, and turn it into simpler metrics. That's the goal here. So there was, I forgot the exact paper title, but there was a paper from Google where they proved that if you divide an image into 9 regions and monitor the 9 equal regions, and monitor them, you can actually detect a lot of like data drift issues from that. So that's one way to think about monitoring these unstructured data is how we extract higher level of order of information. An example in image monitoring is just to extract the brightness of an image or the dimension of an image. Those can affect, like if your model was trained on a different set, like distribution brightness, it might not perform well when the images are presented, darker images are presented to the model, or the distribution of colors. That's another way to think about images. Of course, with text data, there's a different beast, like monitoring the embeddings, but our thinking is how you can never like truly monitor individual images on their own, because they otherwise you're building another machine learning model there, which you can. I mean, some companies do that to kind of like have a surrogate model to monitor these images and try to predict it. And if the surrogate model suddenly predicts something very different, it's a dumb model. It's just try to do some simple prediction, but then it's suddenly like there's a huge distribution of dark in this data set. Maybe the data set has changed significantly. So that's one way to do it. Or another way, using traditional CV techniques like metadata extraction and brightness and hue, and extracting the distribution of data of colors from the image itself. So that's one way to talk about data, unstructured data, and it really depended on the business use case and the kind of unstructured data you're talking about. But it is a very early phase of data monitoring. I don't think there's anyone else who's talking about this as much as we are, just from the space of unstructured data monitoring. It's a very hard problem, admittedly.
It sounds very gnarly, especially when you think about a video.
But one thing about unstructured data we also realized is that a lot of companies are not using they're not building models for these unstructured data themselves. They're actually buying off-the-shelf models, and that target a very particular use case that fits their business. For example, we know that there are companies out there who are doing models that targeting like empty spots in a parking lot, for example. That's a very specific use case. And if you can narrow down to that specific use case, you can also turn it into a different kind of like monitoring problem that targets that use case, rather than start talking about monitoring image detection in general. But we're now talking about garage. So we can detect how many cars are there that the model detected in the model, for example, rather than monitoring the like if your model was trained to look at a small garage, and now you're looking at a big parking lot, then that's a different kind of data set distribution, and you might want to retrain your model.
Makes sense. Kind of bring back to structured data a bit. What are your thoughts on where does like master data management fit into data health and data quality checks?
I honestly haven't thought much about that angle. The way I I guess the way I think about this is really comes down to the question um, of ownership and when data fails, who owns that, and what does that mean when you get this signal? What actions you drive from data monitoring? So I don't have a good answer for your question though, but that's how I think about this problem at the moment. Is like, and we haven't figured out a really solid model around data management in terms of data monitoring, because it also varies based on the technology and the company.
Mm-hmm. Yeah, that's interesting. I think frankly, from what I've seen, I think a lot of companies would be very, very interested in solving this problem, especially when you get into the space. So you have like very concrete MDM where it's like, all right, we need business logic that can reconcile customers even across maybe different banks, say, that we purchased or something like this. But then you get into the domain of fuzzy matching, right? And that's a kind of MDM, but it's very statistical. It's like, okay, how do we identify customers across different devices, for example? And it still seems to be a very hard and unsolved problem. And so if monitoring could contribute to that, I think a lot of companies would be very excited about that.
Yeah, like my friend Scott Taylor, he's an MDM guy, and he's I think it's partly because he is an MDM person that he says MDM is like the root of all, or lack of MDM is the root of all data quality issues. I would somewhat agree and somewhat disagree. I think a lot of the MDM tools are also prohibitively expensive and out of reach of a lot of companies.
Yeah,
it's hard to implement. I mean, we know people who oversee MDM projects, and this is not a light thing. But it seems like this is a really big opportunity if somebody wanted to take this on. Wink, wink.
So Zillow has has written a few blogs about their data contract solution, which is fascinating because they don't necessarily manage they don't really have a master record, for example. But what they do is have a contract that checks for records, and team can apply them on their data sets, which is kind of like rather than it distributes the ownership of data across team, but it centralizes the constraint or the contractual parts of data producer and consumers. And that's actually a model I've seen quite successful, because the management of the contract is lightweight than the management of the data. And then if you think about building and infrastructure management, you can really delegate that kind of building and then kind of management of cost of processing of data to teams, so that teams are more cognizant of cost.
Cool. Just made a note to check that out. It's a Zillow.
Yeah. I think that they did a talk at R Square, the community that that in Seattle, and then I'm not sure if there's a blog post, but I remember seeing that somewhere.
Okay, I'm gonna go have a look for that. That sounds really cool. Yeah, it's something I've been thinking about, and I think Matt has too. Just when you think about root causes of bad data, when we're talking about structured data, a lot of it, like you say, you indicated zip codes, for example, right? They just kind of come in randomly. They might have a hyphen, they might not. They might have 3 numbers instead of 5. I don't know. People are crazy that way. But it really comes down to the form validation, how the data is really tracked before it's saved to a database or wherever it's being saved. That seems to be all over the board, really. If there's standards, if they're like, if form fields have, if you can enforce integrity, and that's one thing. But even then, it's so easy to get around a lot of these issues, right? I mean, naming is like a big one. I can first and last names.
Yeah,
they're all over the place. I mean, you probably, you've seen enough examples. I'm sure you can testify for this. And it seems like that attacking things at the root would be smart, but it seems if it was that easy, it would have been done.
Yeah, unfortunately, things like more like intrinsic to the data itself, like names, they're not easy because they contain so much semantic there. Unless you have a way to capture them in form of like embeddings, maybe then you can you can definitely monitor embeddings. But names themselves, like first name and last names, I don't even know how to. Even as humans, you get confused all the time. Right. So an automated system, I think you get a lot of false positives if you try to monitor them in an automated way. Maybe if you have an embedding, but even then, it's gonna be very different from Yeah, I guess if you look at enough data, like monitor embeddings across a large range of data sets, like tokens, like the name map to a token, and look at the distribution of them into the dictionary, like suddenly somehow Smith appears a lot in first name, but it's 2020, that name might not be the most popular name in the data set, and it rises up. That might be indication of a shift in the upstream. But again, it relies on the fact that that change is systematic, mixed up somewhere that causes that. It doesn't it doesn't help when it's an actual change of upstream data that causes by the customer, because people mistype the name. Like that sort of like one-off error is harder to catch in that kind of like statistical monitoring world. You can only catch something that affects the whole data set, not individual data points.
Interesting. Yeah, because that obviously impacts featureization that we kind of discussed. With observability and data quality checks, like how do you approach, ethics and bias are a really big issue right now in the machine learning space. I mean, how does data observability and data health play into that?
Yeah, so I think ethics and bias, just very hard problem. Like trying to go into the explainability space. If you're thinking about it, an explainability problem, like machine learning specific, but I think ethics and bias are actually not purely a machine learning problem, as in you don't need a model to introduce ethics and biases into your system. And from that way, what we've seen so far is a very lightweight technique in monitoring or just running observability is called segmentation. In traditional DevOps, where you tag metrics with dimensions like country equal US, for example. What we've seen successfully done in this space is to think of, you need humans first to think about the problem, like what are the potential dimensions that might contain biases, that might introduce biases or causes ethical problems, and then you monitor each of those dimensions as well on top of the whole data set. So you don't have to monitor thousands or hundreds of thousands of dimensions. You might reduce the problem to a few hundreds, or think about like zip codes, for example, which at least in the US indicates a lot of inequality. So you can monitor your system behavior based on zip code and compare. I mean, if they are next to each other and somehow you see the system output very different, there might be some bias in that data set, and you have to be cognizant of using that data set for training or using it against a machine learning system that wasn't trained, that doesn't have that defense mechanism built in for this sort of bias. So that's how I think about this, is how we can monitor this in a lightweight mechanism and it's a way more explainable than using explainability technique, and way cheaper as well. So and it can be done at the data pipeline point of view, even before the data gets into the model rather than after the fact. And this is not limited to just models, but it is a data problem. So we can have some guardrails to defend against this. I don't think I haven't seen any solution out there that solves this in a truly automated way without human input, because at the end of the day, I believe these problems are very social problems, and therefore has to solve, like the input has to be driven and guided by humans, rather than letting a machine learning or an automated system somehow figure out all the magical biases in the data set. That's not going to happen, because it's like banking problem is going to be different from retail problem, for example.
Any thoughts, Matt?
Yeah, that's interesting. I mean, I feel like we're going to be arguing more generally about observability for a long time, actually, and about explainability. It really feels like you do have to dig into this data and determine where those biases are, where maybe you expect them to be, and to see if they actually show up. And then if we can't explain the biases, maybe that's not a big deal, but that's where the big debates and arguments are going to be about whether we should be able to explain them or not. And then what the response is, if we can detect them, how do you fix the models so they don't show those biases anymore?
Yeah, and I don't mean that we have to defend against all biases. There are some inherent biases in the way human data is generated, but we can definitely have awareness around that there's a potential bias to this model because we take the data from this data set which contain these biases. And at the moment, it's a very very lengthy manual process. Somebody has to run tons of queries or analysis on the data set to detect that. And when companies are moving fast, I just don't feel that it's built into our mechanism to think and build or incorporate into the process of like building a system to first try to detect biases in data sets. Like we need an automated way to like suggest this somehow or guide us somehow and via previously known signal. Like human doesn't have to run an hour of analysis, but somehow you can just put in some tweak and configurations. Hopefully the system will run the analysis for us.
I mean, one core problem here, let's be frank, if I am in retail, then I'm looking for people who will spend money, right? That means inherently my model is intended to be biased towards people with more money. That's what it's supposed to do.
Yes.
And yet, how do you do that with like and make sure that your model is not like racist and classist and a lot of other things that your model could be behind the scenes? And that's the really kind of scary question here, right? Like, how do you target people but also be fair and not perpetuate the existing problems of society?
And there's a kind of like unintended consequence problem as well. Like once you roll out a model, you might put in all sorts of defense against biases, and maybe it might be biased, but the bias you're introducing you think are not consequential, but somehow downstream it will reflect in the data set somehow or some other data set. It's hard to say.
Well, and this becomes interesting too with reverse ETL, or as I call it, BLT. Now. Sandwiches for all. But it presents I was talking to a person who runs a data team who's doing a lot of reverse ETL right now, taking data out of their data from a CRM into their data warehouse, running some lead scoring or whatever they're doing, and putting it back into their CRM. And he's like, it's interesting because before, if you just munge data in your data warehouse and just present it to the business, you could sort of get away with maybe being slightly wrong. Now that it's going back into a CRM and salespeople are taking these leads and doing something with it, the consequence for error has just gone up a ton, a lot. And he's like, it presents a very interesting feedback loop now between like reverse ETL going back into your transaction system, and then that same data feeding back into your data warehouse. So that's
that is a compounding effect. That's just a bit scary. I mean, we've seen that in with insurance companies where it's not so far. I mean, they work a lot on Excel spreadsheets, the analysts, but they do have all the big data system and whatnot, and it's kind of like they feed the spreadsheet back into the data warehouse, and then they also extract the data from data warehouse to run analysis, and it creates some interesting effects there.
Yeah, it seems like maybe some technique for monitoring or detecting feedback loops is needed, because in many cases you might not be aware that there's a feedback loop. Like someone somewhere is feeding data back in that somehow is downstream from your model, and you don't realize this, and then it goes through a couple of transformations, and the signals are somehow getting back in your model. There's got to be a way to do this, right?
I mean, there's Lineage try to solve that. I think everyone should try to do Lineage because it's very important, even for machine learning, let alone the data ops. But that, of course, dependent on what kind of Lineage tracking infrastructure they have.
And so then it becomes, if you have a lineage, then it becomes like loop detection and garbage collection, like looking for enclosed loops that you need to garbage collect because they just point to each other. Interesting.
Yeah.
Or sometimes people just not gonna take any actions. If you're working in sales and you're just trying to like crunch through the numbers, and the incentive models have to align here somehow.
It does, and what I normally see with salespeople, especially if the system isn't working, they're just going to do something rogue on their own because they have no incentive to fix the problem that was handed to them, and so they're just like, well, screw it. Your lead scoring sucks. I know it all up here. I'll just do it. In which case, I think in some cases it's fine. Like if you know your customers better than what's being provided to you in the data, then that's for the salesperson, that their fault. That's the data team's fault for not providing a better than expected list of scores. So well, I mean, the salesperson knows their customers, hopefully, so I would say that takes priority. But yeah, but what would happen is basically, well, again, it's a feedback loop because the salesperson is going to go off on their own. The system won't know any better. They're going to think it's perfect, right? And it's actually going to get worse over time. So yeah, that'll be.
Yeah, that's a human problem here, and it's not just simply a technological problem anymore.
But again, that's where I think a lot of data problems, stem from, is just human problems, like misaligned incentives in terms of creating good data in the first place, human generated, or people not using data and it just kind of goes stale, but you just use it anyway. I'm almost done with this really good book I was reading called The Tyranny of Metrics. It talks about how metrics are good, but they can also be misused in a lot of cases. Like, I think one example in the book was, focusing on everyone should go to college, and then lowering the bar for admission scores. And then basically it becomes a self-fulfilling prophecy where it's like, hey, if everyone's a winner, like nobody's a winner at this point, right? And so, but it just, the use of metrics kind of, because I think everyone, especially in management science, wants to sort of, take scientific approaches and apply them maybe where they should be applied, and in a lot of cases probably where they have no business being applied. And so what happens, you start getting these, I would say this, metrics that probably shouldn't be there in the first place. So just because they're kind of silly.
Yep.
My friend growing up, one of my friends' dad was in the Air Force, and he was telling the story about how the base commander decided that they really needed to save fuel. So he gave an order that no plane would take off with more fuel. Like they take off with fuel plus reserves for the trip and nothing more. So they weren't carrying extra weight. Well, in practice, what happened is the planes were overfueled, right? They would fuel up and like, oh, we have too much fuel. So they would sit on the ground and burn off fuel until they took off. And that's the problem. Like, machine learning models can end up doing exactly the same. If you're training to metrics, they can end up having all these bizarre unintended consequences. I mean, this happens with human systems, and as machines get smarter, it's going to happen more and more with machine systems too.
Oh, well, and this is kind of poses an interesting dilemma for like observability, because it's like you'll be observing things that I think are on paper correct, but is it like in practice correct? I don't know.
Yeah. That's what I meant by you gotta do it every stage of your pipeline. And it's like if you don't do like print, or if, when you ask an interview question for engineer, how do you debug your system? And you'd say, oh, I do printf, or I use Python logger, whatever. At least you have to log somehow. It's like a malpractice. If like you have to debug your system somehow. But at the moment with machine learning operations, like, oh, we're like, we've seen a case where, oh, we're like double bidding, and now we're winning all the bids because our system saw double amount of data, and we did not know until it shows up on our business spreadsheet. And that is just a case where people are just literally flying blind when it comes to all these models or data system operations. There's not really like, you don't see changes across the stages, and even a simple things like log out the count of like okay, you might not have the resources to build in a data ops, but log out the count of your data stream. That's a simple solution to have a sanity check. And if it suddenly spikes up, that's something very wrong. Of course, once you start doing that, you realize it's insufficient and you want to go deeper, but you have to start somewhere.
That's awesome. Well, cool. Looks like we're coming up on time. I also want to give a shout out to your redesigned website here.
Let's show it.
Joking before the talk started about you want to give a quick story on the dog?
Oh yeah. So before we came out of stealth, where we reached out to candidates, we of course would introduce ourselves as WhyLabs, and people would be like, who the hell is WhyLabs? So they type in WhyLabs in Google, and all they got was why Labradors are the best dogs. So here we are with a Labrador, with a robot Labrador, hopefully with some smart enough AI, but a Labrador.
That's awesome. And you guys have a couple of things going on. You got WhyLabs and you got WhyLogs. You want to explain the difference of those?
Yeah. Yeah, WhyLabs, we're trying to build a platform, but one of the things I'm most passionate is about WhyLabs, actually, where we're trying to solve it's an open source project. What it does is it tries to log your data statistics rather than logging your the simple DevOps metrics. What it does is logs aggressively across multiple dimensions and statistics. And once you do that, you can put them side by side and start viewing, like observing the differences at different stages of your data pipeline. And because it's the data and machine learning package, it actually comes into two flavors, Python and Java. So check it out. It's an open source package. It comes with other integrations like MLflow and Flask. So you can do like various. It works with like real time system where you're deploying a live model, as well as a batch system like Apache Spark.
That's awesome.
So I'm really passionate about it, because the way I think about solving this is that we have to build a standard around data logging, and then build up about the best practices around this.
That's cool. Yeah, big fan of what you guys are doing.
Yeah,
it's awesome. Cool.
Thank you.
Yeah, of course, and thanks for coming on the show. Yeah, again, go to WhyLabs.ai, learn more about Andy, and obviously, subscribe to our YouTube at Ternary Data. Just search for it there. Also, we have a newsletter at ternarydata.com. You can subscribe to our newsletter. We have exclusive content that comes out every week, along with awesome links, curated data articles, and so forth that we find. So definitely check that out if that interests you. And Andy, it's always a pleasure talking to you.
Yeah, thank you, Joe.
Yeah, of course. I feel like I always come away a bit smarter than when I started. So
thank you, Matt. Yeah.
Thank
Take
you.
care.
Yeah, great to connect, and we'll talk to you soon.
All right.
Yeah,
Thanks.
talk to you soon. Bye.
Bye.